In this lesson, we're looking at formulas for prisms and cylinders. So you see that they're kind of explaining once again, and I say again because you've seen the concept of volume before, that volume is how much space is within a solid figure, how many cubic units are inside a solid figure. And then you have the definitions for a right prism with a diagram and a right cylinder with the diagram. And with a definition for right cylinder in the diagram, please note this vocabulary because it will come into play a little bit later. The axis is the segment that is connecting the two centers of the cylinder, and in a right cylinder, that axis is perpendicular to the two bases. So in this Explore activity, they're describing the process of creating a solid. And so certainly I'm not going to do that in this video, but I will kind of talk you through how they're using this activity to develop a formula for the volume of this kind of prism. So they said, let's make a quadrilateral shape, and we'll say that its area is B, B being just some number. So if B, this quadrilateral, is the base of a prism, and I make a block of styrofoam and I cut it to shape the base, and I make the height of that styrofoam 1 inch, how would changing the area of the base change the volume of the prism? Well, if I increase the area of the base, that would increase how much styrofoam I need to fill it. So increasing the area of the base would increase the volume of the prism. So if the base has an area of B square units, then how many cubic units does the prism contain? Well, in this example that they were talking about, the height would be 1 unit. So it would require B cubic units. And so if I change the height of the prism and I make it H units, then how much greater is the volume of this prism compared to the one with a height of 1? It is H times greater. Suppose the base of the prism was a rectangle having sides L and W. Write a formula for the volume of the prism using L, W, and H. And this definitely should be a throwback to middle school. The volume would be L, W, H, length times width times height. You've seen this before. So a cylinder has a circular base. Use the result of the Explore activity to write a formula for the volume of the cylinder. So in the Explore activity, what we noticed is that we were taking the area of the base and multiplying it by the height. Okay, so let's use that reasoning. The volume would equal the area of the base times the height. Well, in a cylinder, I have a circular base. So how do I find the area of a circle? It's pi r squared. And this is, in fact, our formula for the volume of a cylinder. A couple of formulas here for finding the volume of a prism. The formula for the volume of a right rectangular prism you see is length times width times height. If it's a cube, length, width, and height would all be equal. So if I were to call it S, then I would just take S to the 3rd power to find the volume of that cube. So let's use volume in a real-world situation. Here I know that a gallon is equivalent to approximately 0.134 cubic feet. I have the dimensions of this tank. So we found the volume of it here. and then used a conversion factor to estimate the volume in gallons. So you could think of that as being over 1. They multiplied straight across the top, straight across the bottom, and divided, and got 429,851 gallons. Then they want to estimate the weight of the water using this conversion factor. And so again, I can think of this as being over 1, and then straight across the top, straight across the bottom, and then I work the math out. Similar idea here. I am given the density of ice, the density of water. What am I trying to find out? It says ice takes up more volume than water. This cubic container is filled to the brim with ice. Estimate the volume of water once the ice melts. So we're going to find the volume of the cube of ice. So since it's a cube, I would do s to the third power, so that's 3 to the third power, which is 27. And then we're going to convert that volume to mass using the conversion factor 0.9167 grams per cubic centimeter. So 27, again, I'm going to put it over 1 just because it makes it easier to look at, times 0.9167 grams per cubic centimeters. And so in my calculator, I work that out to get 27 times 0.9167 . 24.7509. In step 3, we're going to use the mass of ice to find the volume of water. So we're going to use the conversion factor here, sort of. Notice how we want our answer to be in cubic centimeters. Notice how this unit of measure has the cubic centimeters in the denominator. I don't want the cubic centimeters in the denominator, I want them in the numerator. So I'm going to write that conversion factor as 1 cubic centimeter per gram. So I'm multiplying 24.8 grams times 1 cubic centimeter per gram. My gram units cancel out, leaving me with 24.8 cubic centimeters, which, notice, is less than my original volume, which makes sense because they told me back here that ice takes up more volume than water does. So the general formula for the volume of a prism is volume equals base times height. Suppose the base of a prism is a parallelogram with length L and altitude h. You use h as the variable to represent the height of the prism. Write a volume formula for this prism. It would be volume equals LH, because that's how I find the area of a parallelogram, times capital H, which represents the height of the prism. In your turn number 4, they're asking us to find the volume of the figure. Notice that we are told that each box represents 8 cubic units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 8 is 88 cubic units. In your turn 5, a little bit more involved, each cube has a side of 2k. The volume of a cube, remember, is side cubed. So this would be 8k cubed times 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 times 8k cubed is 72k cubed. We're also going to find the volume of oblique shapes. And an oblique prism is basically a prism that is slanted. An oblique cylinder is, again, same idea. It's a cylinder that is slanted. Consider maybe the Tower of Pisa. Same idea. So we have this principle that we use for finding the volume of an oblique prism or oblique cylinder. And it tells us that as long as all of the cross sections are the same at every level and their heights are the same, then their volumes are the same. So in example 2, they found the volume of this oblique cylinder, and the base of it was given to us as 81 pi. The height, we were told, is 3 times that of the radius, and so they used the area of the base to find the radius. They worked backwards from the formula to find that the radius was 9, so then the height is 3 times that, and then they took those values and plugged them in. Here I am given that the base, the area of my base is 75. I am told that the height of this oblique square-based prism is 4 times that of the side length of the base. So if the area of the base is 75, well, the area of the base is a square. So that's side squared is 75. So that means each side is the square root of 75. So I know that the height is going to be 4 times s, because they told me that up here. Use the area of the base to find s. We just did that. So then the volume will be 75 times 4 times the square root of 75. And it says rounded to the nearest tenth. So square root of 75 times 4 times 75 is approximately 2,509. Oh, that's ugly. Sorry. Here we are given the radius and height of the cylinder. Remember that the formula for the volume of the cylinder is pi r squared h. So pi times 12 squared times 45. The instructions don't say anything about rounding, so we're going to leave the answer in terms of pi. So 144 times 45, my answer will be 6,480 pi cubic inches. Remember that a composite figure is just a couple or a few simple shapes put together to create a more complicated shape. And so in example 3, part A, you see a cubic base with a oblique cylinder on top of it. And we're given the height of the whole figure and the radius of the cylinder. So let's see how they used that. They found the base area for the cylinder. They realized that the cube has a side length that is equal to the diameter of the circle. So that means that the length of each side of the cube is 10. And so the height of the cylinder, since this is 10, the height of the cylinder is 12. They found the volume of the cube by taking s to the 3rd power. They found the volume of the cylinder by doing pi r squared times h. And then they added them together, which you see here. In part B, we have a periscope made up of 2 cylinders and 2 right triangular prisms. So let's see what we have. We have that the height of each cylinder equals 6 times the radius. And we know that the area of this base is 36 pi, so that equals pi r squared. And if I set up this equation and solve it, then I would divide both sides by pi. R squared would equal 36, so r would equal 6, which means that my height, therefore, is 36. So I know pi r squared was 36 pi, so r was 6. 6 times 6 is 36. I'm just filling in these blanks with what we did off to the side. The faces of the triangular prism that intersect the cylinders are congruent squares. So I know that the length of each side of that square will be equal to the diameter of the base of the cylinder. So the diameter is 2 times 6, which is 12. So 2 triangular prisms form a cube. All right, so what they did is they took these 2 triangular prisms and put them together to make one cube whose side length is 12. So they did 12 to the 3rd power, which is 1728 cubic inches. Find the volume of the 2 cylinders. That's 2 times, because there's 2 cylinders, 36 pi, which is the area of the base, times the height of the cylinder, which is 36. So let's go ahead and evaluate that out. I have 2 times 36 times 36 times pi. That is 8138.9. The total volume is the sum of all of these individual volumes. So that's 1728 plus 8138.9, which is approximately 9,866.9.